Hi, welcome back to Agastya Technologies Theory of Computation courses. In this session, we are going to discuss Theory of Computation Prerequisites. The prior knowledge to go through the theory of computation. It is very important to understand the fundamentals. That is the reason we are spending some time to recap the prerequisites. In this one, the part 1. This is the part 1 of prerequisites. In this session, we are going to discuss about sets, functions, and graph. As the part of sets, we are going to elaborate more on what is set and natural numbers, which is denoted by using this letter, capital N, and integers, and what is empty set, union, intersection, complement, and cross product is denoted like this: n cross n equal to I j tuple slash I and j greater than 1. Then we are going to elaborate more on what is tuple and the sequence, power set, and also we will discuss about Venn diagrams. What is a set? Set is nothing but a group of elements. Group of elements are group of objects. In the set, a set may contain any type of objects, including numbers, symbols, or even other sets. For example, when we say a set of 1, 2, 3, this is a set of numbers. Set of symbols like A, B, C. Again, a set consisting of another sets, like we can say this is the set which is having other sets as an elements. So that's what here the elaborating sets may contain any type of objects, including numbers, symbols, or even other sets. The objects in the set are called its elements or the members. So the elements of the set is 1, 2, and 3. The elements of the set is A, B, C. The elements of the set is, this is called one element, and this is called one element. So the number of elements here is 2. The number of elements here is 3, and the number of elements here is 3. Sets, the formally, this is the notation we use, the flower brackets, and the elements are separated with the comma. Now, when we going to continue the set, so the set of integers, the common notation we use called Z, and so the dotted 3 dots means many elements here, then -2, -1. This is the notation we follow. The set with the 0 elements is called empty set, and it is written as empty set. Is the notation followed is empty set. And if you want to represent that one in the formal notation, we have to represent this one. So if you want to define in the formal notation fashion, you can define like that. If you're writing somewhere this, then it is an empty set. A set with one member is sometimes called a singleton. Singleton means one. Singleton means one. If any element with one element, and a set with the 2 members is called unordered pair. So if the set with one element, this is singleton, and you can say A, B, C. This is also a singleton. This is also having one element. and set with the two members is called unordered pair. Now when we continue, what is infinite set? An infinite set contains infinite elements. So when we say 1, 2, 3, when we say 3 dots, means many elements, infinite elements. This is what the set, when we say natural numbers. We cannot write a list with all elements of an infinite set, so we use 3 dots as a convention to say it is infinite. So the natural numbers, when we say 1, 2, 3, 3 dots, then it is infinite. We are going to elaborate more on countable, non-countable in our TOC. Again, infinite sets also be classified, but we are not going into those details now. But we are only restricting as infinite set. Next one, now this set, then the convention, if when we are writing a set A, B, C, if any element, these are elements, if element belongs to A belongs to S, or A does not belongs to, so to use that one, we can say belongs or does not belongs to. Belongs to means is a member of set, does not belongs to means like 7 does not belongs to S, or A belongs to S. This means 7 is not a member of S, but A is a member of S. Now, what is a subset? What is a proper subset? We can say A is a subset of B if every member of A is also a member of B. For example, A is consisting of B and B equal to A, B, C. So each and every member of A is also a member of B, then A is called subset of B. And we can say what is a proper subset and subset. We can say here if A is a subset of B and not equal to B, what is the meaning of this one? When we say A is AB and when we say B is ABC and A is a subset of B and also we can say a proper subset. If we are returning as if the A set is consisting of 3 elements like ABC, in this case also A is a subset of B, but it's not a proper subset. Proper subset means if both are not equal, see if A need to be, if A and B, when we say a proper subset, A need to be a subset of B and A is not equal to B, then it's called proper subset. Why it is coming in here? Every set is a subset of itself. Like we can say B is subset of B, yes, but it's not a proper subset. So that's what is a proper subset. Now we are not going to use this here. So proper subset is written like this. If it is not a proper subset, like we are going to write like that. So this is what subset and proper subset. Now the set operations, we going to have two. If we have two sets, A union B, if A is consisting of ABC and B is consisting of 1, 2, 3, then the A union B is A, B, C, 1, 2, 3. So this is the Venn diagram. This is the, if there is, this area is a common area. If any element, for example here, if you have X here and X here, this is what the common element here. So here A, B, C and 1, 2, 3. The union of A and B is written as A union B is the subset we combining all the elements of A and B into a single set. So A union B is not we can use some X or S into a single set. What is the intersection of B? What is the intersection? So what is the common elements between A and B? In the case of A union B, we are combining all the elements of A and B into another set. Another set. We are taking all the elements. But in the case of A intersection B, we are taking common elements. So here X, A, B, C, 1, 2, 3, 4, 1, 2, 3 and X. So definitely the intersection is X, the common element. The complement of A is also written as like this. Complement is the set of all elements under the consideration that are not in A, that are in the universal set. Means S minus, if S is a universal set or U is a universal set, A complement equal to U minus E. We can follow this notation like universal set minus A. This is the complement. Now we are coming, so in the set, what are the main attributes? In the set, duplicates are not allowed. You can't write like this. So this is in S. And also the order is not important. So you can write the set in this fashion or in this fashion. The order of the elements is not important, is unordered. Unordered. So now it comes to the sequence. What is the sequence? What is the main difference between sequence and set? A sequence of objects is a list of these objects in some order. So when we say like this, it takes the order is the important. When we see like this is one sequence. When we say sequence S1, the order is important. When we are writing 1, 3, 2, this is a different sequence. This sequence is different from this sequence. But in the case of sets, when we are writing set S1, 1, 2, 3, or we are writing S2, 1, 3, 2, there is no difference between these two sets. The order is not important. You can either go either in this fashion or in this fashion. But in the sequence, the order is important. That is the reason set we will use this flower basis to denote, but the sequence we use parenthesis. In the sequence, the order is very important. We usually designate a sequence by writing the list within the parenthesis. For example, this is the sequence. So this sequence is different from, you can say 57, 21 and 7, this sequence. Now when we compare the order, the sequence and sets, the order does not matter in the set. This is very important. Unordered. Unordered and the duplicates are not allowed in the sets. But in the sequence, it does matter. The sequence, the order is matters, but in the set doesn't matter. Now we can say this sequence is not same as this sequence, but instead of using parentheses, if we use flower bases here and here, both are the same because it becomes a set. Similarly, a repetition does matters in sequence, but does not matter in a set. So when we say the repetition, for example, now if we see like 1, 2, so when we say this is the repetition is not allowed. If we write 1, 2, 1 or 1, 2, both represent the same set. There is no need to write the duplicates. So in the set, repetition does not matter, but in the sequences matters. Now we can say this sequence 7, 7, 21, this is different from these two sequences. Then now we can say, but in the case of in the sets, this set and this set are identical because this is a duplicate. So that is important. So order does not matter in the sets, and a duplicate is also does not matter in the sets, but in the sequence it matters. Now, what are the common things? Both sequences and sets both are finite or infinite. And again, in the case of sets, the infinites also be classified into two types. That one will elaborate later. Now, finite sequences also called tuples. What is a tuple? What is a tuple? Tuples. What is a tuple? Finite sequence. Like example, when we say like this, it is a finite sequence. Is a 3 tuple. 2 tuple is also called ordered pair. 2 tuple, k tuple, like we can say A, B, C, D, 4 tuple, k elements, k tuple. Now, sets and sequences may appear as elements of like the same what we discussed. Set can consist of other sets as an elements. Now we are going to discuss about if there is a set A, what is P of A, power set. What is the meaning of power set? Now when we say set A, B, C, empty set is a subset of A. Empty set is a subset of, if you take any set, empty set is automatically a subset of that set. Next, when we take only A, this is a subset of that, and then only B is a subset, only C it is a subset. Now we can say AB, either AB or BA, doesn't matter, order is not important, AB, and BC and AC. AC or CA, doesn't matter. So this set is a subset of A, subset of A, subset of A, AC is a subset of A, BC is a subset of A, AB is a subset of A. Again ABC, this is also a subset of A, but this is not a proper subset, the remaining are proper subsets. So if you write any set, when you write any set, P of A is nothing but consisting of all the subset including empty set. This is one element, another element P, and another element C, next one AB, AC, and BC, and ABC. So a power set is a set consisting of all the sub-elements of S including empty set and S itself. These are two important. Including empty set and the set itself, because if you take any set, it is a subset of that set itself. That's what the power set is of. Now this is an example here. If the set 0, 1, then what is the power set? Empty set, and that set is included, and 0, 1. Now in the sequence and tuples, when we are going to discuss about the Cartesian product, cross product. What is the meaning of a cross product, Cartesian product? If A and B are two sets, the Cartesian product, cross product of A and B is written as like this. It is a set of all ordered pairs. This is very important, very important. Ordered pairs. We'll elaborate more on this here. Wherein the first element is a member of A and the second element is the member of B. When we say ordered, when we say A cross B, it is a set of all ordered pairs. When we can say ordered pairs here, first element is nothing but from A, second element from B. If we write B cross A, then the first element belongs to B and second element belongs to A. These two are separated with comma. Now, in this example, when we take A12, B, X, Y, Z, then A cross B, the first element will take 1 and the first element of B, X, then first element of from A and second element. So from first element we have to take all these elements, 1 element, 2 and 3. So 1x, 1y, 1z and 2x, 2y and 2z. If we write B cross A is going to be different. Then x1 and x2, y1, y2, z1 and z2. So that's what the Cartesian product. It consisting of all ordered pairs. So when we say in general A cross B equal to ordered pair x comma y such that x belongs to A and y belongs to B, like this. Now the Cartesian products over, like we explained, over 2 sets. Now we can define over k sets. So A1, A2, A3 is written as the Cartesian product of, like this, is consisting of a tuple. This is k tuple. That's what we discussed. What is a tuple? This k tuple, the first element from A, second element from A1, second element from A2, like that, so on. K element is from AK. Like the Cartesian products of 3, it is nothing but A, B, C. Then A belongs to A, B belongs to B and C belongs to C. That's what here the Cartesian products of A, B and A, like this. If you have a Cartesian product of a set with itself, like if we instead of, like for example, Cartesian products of 2 sets, instead of Cartesian product of like A and A, k times we can say, like what we can say a Cartesian product k sets, a Cartesian products of A k times, we will use this convention. So instead of that, AK means A2, A3, A4 of the same set. The set ends, like we can say this one, n power 2 we can say is equal to n into n. It consisting of all ordered pairs of natural numbers. We can write this fashion. Now this is the discussion now of the basic discussion of the sets. Let's now elaborate more on functions. The functions. What is a function? Function f, when we say function f here, f of AB, function f is a rule that takes input from a specific set, is called domain. This is called domain, and produces the output from another set, is called codomain. So the domain is A and the codomain is B. It is specify a rule. It takes the inputs from this set and produces the outputs from this set. Or also we can call as function is a mathematical process that uniquely relates the value of one variable to the value of one or more other variables. So the variable A is mapping to variable B. This is the function f. So function f, like again we're going to write y is equal to f of x. X is a input variable, y is the output variable, the function is f. The examples of function cos x, exponential, sin x, cos x, nx, tan x, like that, these are different mathematical functions. A function is also called mapping, and if f of a equal to b, then we also say f maps, like when we say f of a equal to b, or we can say like this. There are many ways we can define. So if a maps to b. The set of possible inputs to a function is called domain. As we discussed previously, this is domain. The outputs of a function is called the codomain or the range. The notation for the same is called a domain is D, or codomain is R, or range is R. In the case of the function like ABS, if you are working with integers, the domain and the range are Z, so then we can say Z and Z. So f means that ABS function. So ABS, that is a function which is mapping from this domain to this domain. Now consider another function. Now previously we discussed the ABS function which is mapping from Z to Z. Now this is another function f. This is the domain, nothing but A, and this is the codomain, nothing but B. What this function is, like we are going to define this function. This function adds 1 to the input and then outputs the result of mod 5. So whatever we are giving the input x, then it adds 1 and the module of 5 means the remainder of 5. For example, in the case of 2, the remainder of then 1, the remainder is 2, then 3 remainder 3. Then you can take how to calculate the remainder. Then you can divide 5, 0, then you can say then 5 1 is 5, the remainder is 0. Then you can say 6, then 5 1 is 5, then remainder is 1. So in the case of n equal to 0, what is the f of n? We are trying to add 1 and remainder. 1, remainder is 1. If the input is 1, 1 plus 1, 2, remainder of, like module 5 of 2 is 2, and it 2, 3, 3, 4, then 4, 0. So this is the function. So when we write a function, what is the function? Is taking the input, adding the value, and producing the module of that input. This is the function is mapping. So when we say mapping here, 0, 1, 2, 3, and 4, then this is a mapping 0, 1, 2, 3, and 4. Then 0 is mapping to 1, 1 is mapping to 2, 2 is mapping to 3, 3 is mapping to 4, 4 is mapping to 0. This is the function f. Now function types, when we say the function types, binary, then 2 inputs, then k array functions, k number of inputs, and a unary function taking 1 input. In the case of binary, as we discussed, two inputs and produces one output. Unary takes one input and produces two outputs. In the case of unary, -2, like R++ pre-increment. This is also unary operator. Then in the case of binary functions, then a plus b, when we have two operands, 2 plus 3 equal to 5 and 7 minus 3 equal to 4, then in the case of binary operator. So unary functions, binary functions, k-array functions, and predicate and property, this is also called Boolean function. Here the codomain is a Boolean. So when we have f d mapping to a Boolean, means either true or false, then that is called a predicate or a property. In the case of k-array functions, now you can see it is having a1 to ak for some input and mapping to one value. It taking inputs to f k tuple. What is a tuple? A finite sequence. So in the case of k-array, then we have a k tuple as an input. Then a function with k arguments is called a k-array function, and k is called the arity of the function. What is the arity of the function? The number of inputs the function takes. In the case of unary, the arity of the function is 1. In the case of binary, the arity of the function is 2. In the case of k-array function, means the arity is k. If the k is 1, that is called single argument, also called unary function. If the k is 2, then that is called binary function. A property or a predicate, this is called a Boolean function. The reason it is called Boolean function is a function now is a domain. The codomain or the range is having only two values, either true or false. Means f of a and is mapping to a Boolean, either true or false. This is what is called predicate. Means predicate function whose range is having the Boolean values. So predicate or a property is a function whose range is having a set of Boolean values, either true or false. Now then if we have a function called maybe even, if we have a function even of 4, then is true. Then even of 5, then false, like that. A property whose domain is k tuple is a relation, k-array relation, and is a k-array relation on. If in the case of k-array, then what is a k-array relation? K-array relation or k-array property. We can say k-array relation or property means the domain is the k number of input, k tuple. If the domain is k tuple, but the range is either true or false, the same thing. A common case for two arrays is called binary relation. So in nutshell, so the property, when we say property or predicate, is a function whose range is included the Boolean values. And if the property is having a k tuple, then it's called a relation. Then if it is having k number of inputs, then it's called k relation on set A. Now there are three forms of expressions. One is called infix form, postfix form, prefix form. What is the in? In means between. So when we say 2 plus 3, the operator is between the operands. This is called infix. Now we can say 2 plus 3 multiplied by 5. Then this takes the precedence because of the parenthesis. Then it is 5 into 5. So in all these cases, the operator is between the operands. So that is what called infix. So if we take the infix here, identifier, operand and operator is between the operands. Now the postfix. Post means after. After means 2, 3 and plus. Means operand or identifier and the operator. This is nothing but what is the equivalent infix form? 2 plus 3. The equivalent infix form and the equivalent postfix form means the operands are appears before the operator. That is the postfix form. And the prefix, pre means before. Then we can say plus 2 and 3. The equivalent infix form is 2 plus 3. And equivalent postfix form is 2, 3 plus. Means in the postfix form, the operator appears after the operands. Post means later, after. Pre means before. The operator appears before the operands. So these are the three forms of writing expressions. We can convert one form to another form. Infix we can convert to postfix. Post we can convert to infix. Infix we can convert to pre. Pre we can convert to infix. Post we can convert to pre. Pre we can convert to postfix. Now the relations. What is when we say a relation R is an equivalence relation? Equivalence relation. A special type of binary relation. We discussed here the relation. A property whose domain is K tuple is called a relation. A property. What is a property? A function whose domain, whose codomain or the range is nothing but true or false. Then that is called a property. A property whose domain, we are talking about the domain, is a K tuple, then that is called a relation. Now we coming to here a special type of binary relation. That binary relation is called equivalence relation when we can call if it satisfies these three. If the relation is reflexive, and if the relation is symmetric, and if the relation is transitive, then the relation is called equivalence relation. What is the equivalence relation? If a relation is reflexive, what is the meaning of reflexive? We'll elaborate. If the relation is reflexive, number one. If the relation is symmetric, if the relation is transitive, then this relation is called equivalence relation. What is the reflexive? What is the reflexive? If for every x, x or x, for every x, x or x. What does it meaning of that? Now when we have a set as 1, 2, 3, now we have a relation 1, 1, 2, 2 and 1, 3. When we have a set S and relation R, now we can check is this relation over set S is reflexive or not. So according to that, for every x, means for every x belongs to S, then x need to belongs to R. That's what XRX. This is what the meaning is. For every X belongs to S, X belongs to R. Means 1 1 belongs to R, yes. 2 2 belongs to R, yes. 3 3 belongs to R, no. Means R is not a reflexive. If we define the relation this fashion, 1 1, 2 2, 3 3, and 1 3, then R is reflexive? Yes. For every X belongs to X, S, X or X. For every X, X or X. This is what the reflexive means. Now we are going to elaborate on symmetric relation. Is the same example. If we take S belongs to S equal to 1 2 3. Now for every X belongs to S, X1 and X2, or we can say A and B belongs to S, then if A or B implies B or A. If R is symmetric, for every X and Y, if X or X implies Y or X, or for every X comma Y, X or X implies Y or X. What does it meaning is? Here the same case here. Then we can same set as, then we have a relation is called 1 2 and 2 1 and 3 3. If you have this relation over this set, is this symmetric? What is the meaning of symmetric? For all X, Y, X or X implies X or Y implies Y or X. Means 1 and 2 belongs to R, means 2 and 1 also need to belongs to R. Means X is 1, Y is 2. If XY belongs to R, means Y and X also need to belongs to R. If this is X, Y, 1 and 2 belongs to R, means 2 and 1 belongs to R. 3 3 obviously belongs to R. So means this is symmetric. If we take another example of 1 and 2 and 3 and 3, if we take this one, this is not a symmetric because XY belongs to R but not YX. This is what the symmetric relation is. Now we are going to elaborate on the transitive relation. Is we discussed the reflexive and symmetric and transitive. What is the transitive is? If X or Y and Y or Z implies X or Z. For every X, Y, Z, X or X, X or Y and Y or Z implies X or Z, means this is also notation. For every X, Y, Z, X or X and Y or Z implies X or Z. Means when we have a set 1, 2 and 3, then if we have a relation R over the set 1, 2 and 2, 3 and 1, 3. If you have set like this, is this transitive? We can check, is this a reflexive? No, it is not a reflexive because for every X, X or X, no. Is it symmetric? No, because X is 1, Y 2, there is no 2 1, means it is not a reflexive and it is not a symmetric. Is it transitive? You can say X, Y and this is Y and Z and X and Z, means it is symmetric. It is symmetric but not reflexive, and it is a transitive but it is not reflexive and symmetric. So this is the way we can define the relations. If the relation is reflexive, transitive and symmetric, means equivalence. So if we go for equivalence, 1 and 1, 2 and 2, 3 and 3, then this one is a equivalence relation. It is a reflexive, it is a symmetric, and is also a transitive. So if x, this is also is we can say x, this x and y, we can, this one we can't, this is also in this case transitive, so this is also equivalence relation. Let's recap the equivalence relation and a reflexive relation, symmetric and a transitive. When we mentioned about equivalence relation, a relation is equivalence if a relation R is called equivalence relation if R is a reflexive relation, reflexive, and R is symmetric, and R is transitive. If R is reflexive, symmetric, and transitive, then the relation is called equivalence. Then also we talked about reflexive. When we talked about reflexive, for every x belongs to A, x or x. And in the case of symmetric, for all x belongs to A and y belongs to A, if x or x, then x or y, then y or x. Then the last one, transitive, for every x, y, z belongs to A, if x or y and y or z, if x or y, and y or z, then x or z. Then it is called transitive. Then if the relation is reflexive, symmetric, and a transitive, then it is called equivalence. Let's do some examples again to go through this one. Let's see the set A belongs to 3 elements, 1, 2, 3. Then this is the relation is having these elements. Check for the first is for reflexive. Is this one is reflexive or not? What is the meaning of reflection? For every element belongs to A, x or x. Now, in the case of 1 belongs to A, then 1 and 1 need to belongs to R. Yes. 2 belongs to A, then 2 belongs to R. Then 3 belongs to A, 3 belongs to R, means for every x or x, for every x belongs to A, x or x, it is satisfied. Means the relation R is reflexive. Now, in the case of symmetric, for every x comma y belongs to A, if x or y, if x or y, then y or x. For every two elements of A, if x or y, then y or x. In the case of, we can take 1 and 2. If 1 and 2 belongs to R, means 2 and 1 also need to belongs to R. But here it does not belongs to. 1, 2 belongs to R, but not 2 and 1. So x, y belongs to R, but not yx, means 2, 1 is not belongs to R, means it is not symmetric. Now check for the transitive. In the case of transitive, for all x, y, z, for all x, y, z, if x or y and y or z, then x or z. If we take three elements, in the case of, we can take 1 and 2. If we take 1 and 2 belongs to R, means x, y, and y, z. 2 and 3 belongs to R, then 1 and 3 belongs to R, yes. So if we take any three elements x, y, z, if x, r, y, and if these two are satisfied, if x, r, y and y, r, z, then x, r, z, means this relation is reflexive but not symmetric, and it is transitive. This is the way we are going to check, but R is not a equivalence relation. All functions, you can see here, all functions are relations, but not all relations are functions. But not. This is very important. All functions are relations, but all relations are not functions. This is very important. When we can say a relation is a function, for every x value, if there is a relation, for every x value, there should be associated with only one y value. Like when we say domain and codomain, if this is x and this is y, for every x value, there should be only one y value need to be associated. Then that relation is called a function. By default, all the functions we can consider as relation. You can see this relation. If we divide this one into domain and codomain here, then it comes to -3, -1, 0, and -5. Here 7, 5, -2, 9, and 3. Here this -5 is associated with the 9 and 3. Means this relation is not a function. Now take this relation. Is this relation is a function? If we divide into domain and codomain, or domain into range, -3, -1, 0, 4, and 5, then 0, -2, and 3, -1, and -3. So each and every one is -3, 0, -1, -2, 0, 3, 4, -1, 5, and 3. So now this relation is a function. Now I'm going to give one exercise. So please post your comments regarding to this relation specified here is a function or not. The relation is R is the relation, then 1, 5, again 1, 5, 3 minus 8, 3 minus 8, and 3 minus 8, and 1, 5. So please post your comments. Is this relation is a function or not? Thank you very much. All the best and see you guys in the upcoming session.